Now, last class we did regular triangle congruence proofs. This class we're taking it a step further and we're completing what is called a CPCTC proof. Now this stands for, I've written it right below, it stands for corresponding parts of congruent triangles are congruent. CPCTC. What this means is, if I have two triangles and say I know that they're congruent by ASA, right? ASA, angle, side angle. What else do I now know? Now that I know that these two triangles are congruent by ASA, what else do I now know about these triangles?
A is congruent to D.
A is congruent to D. What else do I now know? C is congruent to F. How do I now know this?
Because it's all congruent.
Right. Because I proved these two triangles congruent, it means everything in one triangle is congruent to everything in the other. Anything that is corresponding is now congruent. So C was corresponding to F, so now it's congruent. BC is corresponding to EF, so now they're congruent. AC is corresponding to DF, so now they're congruent. So once we know that two triangles are congruent, we can now state that corresponding parts of congruent triangles are congruent. And we'll get into what this actually means right now.
Can you go back to that triangle?
Sure.
You're on the website, right?
Yes.
What's that mark? Oh, that's a double arc, right?
Yes, triple arc. Oh, here? Yeah, that's a double arc there. So, what is different about this proof versus the proofs that we did last class?
We're doing like the reverse.
Yeah?
They're all sides.
Okay. Wasn't one of the ones that you did in your notebook all sides? I think so. That's not what's truly different. Yes.
We don't have to mark the picture.
Okay. So these ones we didn't have to mark. It already marked it for us. I'll give you a hint. Look at what you're trying to prove.
Proving the angles.
Oh. In all of the proofs from last class, what was it asking us to prove? What are these?
Congruent triangle.
Oh my gosh. We're asked to prove triangles congruent. What are we now asked to prove today? Corresponding parts congruent. So guess what we're going to have to do first before we prove these parts congruent?
Mark the picture.
What do we...
Find the triangles congruent.
Right. First, we have to prove the triangles are congruent. So let's do that first. So, same exact process from last class. What do we do first?
SSS.
Right. We check that everything in the given is marked on our picture, which it is. All the sides are congruent. And I know that they're congruent by what? SSS. Okay, beautiful. So now, because I know these triangles are congruent, what else do I now know?
That each part is congruent to each part.
I believe, what were we saying?
Side, side, side.
Side, side, side. And now what do we know? Because these are congruent by side, side, side. We know what is congruent.
Everything.
Ah, the corresponding parts. So do we now know I is congruent to L?
Yes.
Oh, yes, we do. They are corresponding, therefore congruent. So let's go ahead and start writing this proof.
That's the whole proof?
Yeah.
Dang.
This is the easiest one you can do, right?
Yes.
Technically,
It is the easiest one. So first, what do we write down? Good. Good. And I know they're congruent. Why? How do I know this is true? Hold up. Nope. It's given. Good. Shh. So now what can I say?
The triangles are congruent because
Yes, because I know all of these parts are congruent, I now know that triangle GHI congruent to triangle. Now, what is G corresponding to?
J.
J, right? G is between the 1 tick mark and the 3 arc mark, and J is between the 1 and 3. So G is congruent to J. What is H congruent to? I mean, corresponding to? K. And what is I corresponding to?
J.
I is corresponding to L. Good. So, how did I conclude that? What was my reasoning?
SSS.
By the SSS postulate. Beautiful. And step 3. What am I trying to prove here?
The corresponding part.
Right. I'm trying to prove I is congruent to L. How do I now know that these corresponding parts are congruent?
With the CPC.
CPCTC. Good. And I'm done. And yes, you can abbreviate. Isn't that wonderful? Any questions? Yes, you do have to memorize CPCTC.
What do you count as operated wrong?
Sorry.
Cut it off and just one letter off.
You say, you know what it means in your head. Corresponding parts of congruent triangles are congruent.
I'm not gonna remember that. I'm just gonna wing it, you know?
All right.
I'm just gonna write on my computer.
I think, guys,
Sorry.
I think that I am going to do the third one, and then I'm going to ask you to do 2 and 4. So I'll do the third one. It is harder. It's better than me doing 2 and you guys doing 3 and 4. So let me do this one. It says TS is parallel to VW and TU is congruent to WU, and prove TS is congruent to VW. So immediately, what type of proof are you writing here? It's a CPCTC proof because we're proving parts congruent. So how do I start this proof?
Label.
Label. Good. Mark up your picture. What does it tell you in the given? Good. TS is parallel to VW. What does that mean for us?
We can do the little alternate.
Yes, you can do alternate interior angles with a transversal. So if I'm taking SV as my transversal, what are my alternate interior angles? Good. We skipped number 2. I'm doing number 3. Yep. What else do I know about this picture?
That the SV is a vertical angle.
Vertical angle.
But also T and W.
I know, yes. So the trick to this problem is that the parallel lines not only give you those alternate interiors, they also give you these.
There's 2.
There are 2. They're not needed. They're not needed, okay? But might as well mark them. And then, what did you guys say about these middle angles? What were they? They were our vertical angles. Good. So, how are these 2 triangles congruent? They're congruent by nope.
There's no. It's
ASA.
Oh.
Or what else could they be congruent by? SAA or AAS. Because they gave us a surplus of information, we can choose what postulate we want. So I'm going to pick, I don't know, I guess I'll pick ASA. Yep, I'll pick ASA. So let's start writing our proof. And as always, given goes first. And how do I know it's true? Given. All right. So what was the next thing that we did?
Alternate interior.
We did the alternate interior angles, and because we're choosing ASA, which angle do you think I need to say is congruent to another angle? So I'm doing ASA.
TU congruent to UW.
Say it again.
TU and UW.
Oh, that was in the given. I don't need to restate
Oh,
that.
no.
I don't need to restate that.
T and
Nice.
Yes. So angle, and I'm gonna, just to be overly cautious here, I'm gonna use 3 letters. Angle STU is congruent to angle VWU. And how do I know this is true?
alternate exterior.
Alternate interior angle. Is it a postulate or theorem?
Theorem.
It's a theorem. What? Remember, which is the only one that's a postulate?
Vertical, no. the
Corresponding. Good. So then, number 3, what did we then state? We did. We stated the vertical angles. So, what can I call this angle here?
TUS.
Yeah, TUS, angle TUS is congruent to,
WUV.
yeah, WUV. The vertical angles are congruent, and how do I know this?
Vertical angle.
By the vertical angle theorem. So now that I've stated all my parts are congruent, what do I now know?
Triangle something.
Yeah, good. Triangle, let's do STU is congruent to triangle. What is S corresponding to? V. What is T corresponding to? And what is U corresponding to? Itself. And how do I know this is true? Oh, hold up. Yes, the ASA postulate. Is this what we set out to prove?
No.
No. What is our last step? Good. By why? How do I now know these are congruent? CPCTC. Corresponding parts of congruent triangles are congruent.
So all we have to do is just bring the triangles congruent.
And then put CPCTC. Yeah. Yep.
Just added.
Just one more step. That's all today is.
That's stupid. Why do we even work that?
It's just another type of proof. All right. So now you guys go ahead and do 2 and 4. All right. So I know that most of you finished this number 2, so I'll go over it super quickly here. We have TU is congruent to WU, which it gave us. It already marked them congruent, and T is congruent to W. What is the unsaid thing that is congruent?
Vertical angles.
Yeah, vertical angles here. So we immediately start writing our proof with our statements and reasons. And I write down my given. You guys all diligently wrote that down, so I won't bother doing it for you. And then what did I mark congruent next?
Vertical angles.
Yeah, vertical angle. So angle TUS is congruent to angle VUW by the vertical angle theorem. Then what comes next?
Wouldn't it be TUSWUV?
It doesn't matter. This angle can be called VUW or WV or WUV.
Okay.
It's the same angle.
Okay.
Number 3, we can now state that triangle STU is congruent to triangle VWU by what? How do we know they're congruent? And then what's the last and final step? Good. We now know TS is congruent to WV by CPCTC.
And when's our test?
Next Thursday. Would you also like me to go over this last problem? All right. So we're given the lines are parallel and angle CBD is congruent to ADB. Now, when I'm marking parts congruent and I'm dealing with parallel lines, I'll give you a hint that I always perform. I know that it's sometimes tricky to figure out the angle pairs with parallel lines. So what I do is I trace over the parallel lines, and then I trace over the transversal that's touching both of those parallel lines. And then, for me, I can clearly see what are my alternate interior angles. Right, ABD. It's on the inside of the Z. See that? It's touching both the parallel line and the transversal. That angle is congruent to what? Yeah. And then, what is the last thing that's congruent?
The line.
Yeah, the reflexive side. So these two triangles are congruent by ASA. So we have statements and we have reasons, and you guys all wrote the given, and we know it's true because it's given. Then we marked angle ABD congruent to angle CDB by alternate interior angle theorem. And then we marked the reflexive side BD congruent to itself, BD. And I know it's true because of the reflexive property. Then I now know the two triangles. Triangle ABD is congruent to triangle CDB by ASA postulate. And then I can state BC is congruent to AD by CPCTC. Any questions on this proof? All right.